Is454. I'm Professor Fahmi Jalani. Today we'll be talking about association analysis for lecture 5. So let's take a look at the definition. So technically, is a task of uncovering a relationship among data. Some of the rules basically is a model, identify how data items are associated. Here is an example. For example, it is used in retail sales if to identify that are frequently purchased together. So, for example, a consumer could buy bread and then could buy peanut butter after that. So there's an association. It could be iPhone and then together with iPhone cover. See, that's some example. Right. Also, it's like a if then else rule. Here is the structure of the rule. Basically, if the condition met, then the result. So in this case, if a customer purchase Coke, then the customer also purchase orange juice. Okay, that is the example. Okay, so beverages. Some of the strength of the rule: confidence, where there is a frequent pattern to it. So when we mentioned about a frequent pattern, means high percentage. So confidence levels to A is to B, and then you have the formula. Probability of B is from A. Okay, if Coke, then orange juice. Right, has a confidence of 100%. So how often it occurs? Basically, a measure of usefulness of the rule. So the support is A is to B. Okay, probability of A is B. So for example, if for the rule, okay, if Coke then orange juice, so if there's 5 transactions, 2 contain both Coke and orange juice, so it's 40%. Okay. So it's a situation for rule mining next. Two-step process. Find the frequency K, set K is 1 to infinity, for example. So the item in a rule refers to an item set. So the rule contains a K, item forms a K dash item set. So K is the number of transactions. Okay. So if item set satisfies the minimum support, this is i.e. for example 50% or more, so it's called a frequency item set. Next, take a look at generation strong rules. Okay. So here they mentioned that rules satisfy both a minimum support threshold and a minimum confidence threshold are called a strong rule. So like I mentioned initially, the number of frequency and high percentage will give you a strong rule. Next, take a look at a priori algorithm. This is an item set is frequent, then all of its subset must be frequent. Okay. You see the relationship later on in the diagram. This illustration. Okay. So here on the circle in red, we have A, B. ABC, ABD, ABE, and as you progress down, you have a prune superset. So in terms of algorithm, let k is to 1, the generate frequency item set of length 1, repeat until no frequency item set identified. Okay. Generate length is k plus 1 candidate. And prune candidate item contains subset of length k. Okay. So you count the support of each candidate by scanning the DB, eliminate the candidate that are infrequent and leaving only those are frequent. So how to generate a strong association for each k item set, I generate all non-empty subset. Okay, for every non-empty subset, I generate the rule and associated confidence. Okay, output the rule if the minimum confidence threshold is satisfied. Okay. So moving on, we have a multi-level rule, association rule. Okay, this is difficult to find strong association with very low or primitive level of data. Okay. Here example, few people buy IBM desktop computer and Sony black and white printer together. So many people may purchase computer and printer together. Okay. So here the argument is in terms of brand. Okay. But the true fact that many people buy computer and printer at the same time. Let's take a look at concept hierarchy. This is to define a sequence, basically mapping lower level concept to higher level. Here, the example we have is IBM, the hardware, moving down to software, and moving down to probably a printer, right? And later on moving down to accessories. Some of the steps to be followed: top down, first mine high level frequency item, and then you mine the lower level frequency item. So at the level of a priori algorithm, okay, you use minimum support and reduce minimum lower level. Let's take a look at the sequential association rule. Basically, for example, concerns sequence of event. For example, new homeowners purchase shower curtain before purchasing furniture, right? So an example, when a customer goes into the bank and asks for an account reconciliation, there's a good chance that he or she will close all of his or her account. Okay? So that's the sequence association, cause and effect. Also, we take a look at two additional features, a timestamp or sequencing information. This is to determine when transaction occurs relative to each other. And also identify such account as ID number. Some important parameters, for example, duration may be the entire available sequence in the database or user selected subsequence, for example, year 1999. Event folding window is a set of occurring within a specific period of time, such as within the same day or occurring together. So some other important parameters, interval between events in the discovered pattern. Zero interval means to find strictly consecutive sequence. In this case, minimum to maximum interval, where C is the interval. Some practical issues. time, window, transaction, level of aggregation, and level of support and confidence. Time is basically is the interval. Okay. Time window of transaction. For example, in this case, transaction covers 2 product cycle. A customer purchase a product with a frequency of 6 months or less. Select a 12-month window for a customer transaction. Okay. So in this case, we are assuming that the customer will purchase the product every 6 months. So if a customer purchase the product frequently, so you will just require only short time window. For low frequency item, for example 6 months or 1 year, will have a longer window time. Okay. Level aggregation, if the product codes in the data are too specific, such as based on product details such as size and flavor, okay, few association will be discovered. Okay. This is basically variety of the product. Next, we have group products into categories according to the product hierarchy or create new level manually. Okay. Next, take a look at level support and confidence. Okay, start with high support and gradually reduce it. Okay. Set confidence to around 50% to reduce the number of permutation. Okay. Mention there should be a minimum level. So basically, in conclusion, here association analysis rules such as multi-dimension and sequential association are studied today. Operational algorithm is described in detail. Various practical issues in association rules are analyzed. So if you have any question, please feel free to email me or drop by my office for an appointment. Thank you very much and be safe. Bye bye.